Virtual Reality as a Design Tool to Perceive Visual Disabilities by Jordan Crompton. According to the Office for National Statistics, the UK population grew to an estimated 65 million people in 2015. The percentage of the population that is 65 years or older is increasing each year. It dramatically grew between 1975 and 2015, from 14.1% of the population to 17.8%. This is now projected to continue to grow to nearly a quarter of the population by 2045. The implications of living older coincides with the increase of people suffering with visual impairments, as the majority of people with sight difficulties are over the age of 50. The significance of this and architecture centres around the approved documents. As architects, we meticulously design to the limits of these set out rules, to achieve a design which is centred on the ideal user, only merely creating an accessible building for others. Disability is the constraint we design around. If we could have the chance to better understand the broad spectrum of experiences people have in space, such as older people with physical and sensory limitations, people with impaired vision, or other disabilities, it would allow for an untapped knowledge of varying perspectives to our own. Good design responds to the needs of the people it serves. Design based on experience is where architecture should be heading. Jonathan Bartling, the Director of Research Group HGA, Digital Practice Group. To approach alternative realities to our own would be greatly achieved by the means of entering computer-generated simulations through VR. The limitations that define our physical environment, such as gravity, light, or material, are no concern in virtual worlds. As such, allows for an endless number of unimaginable worlds and senses unbeknown to humans. Nevertheless, within the process of this artifact, virtual reality shall not be perceived as a separate entity, but what can be learned in the transition between the real world into virtual multiverses. A scenario which can represent as a gateway to a virtual layer to explore visual impairments in a virtual environment. A relevant anecdote would be Patricia Moore, who disguised herself as an 80-year-old woman with the intention of better understanding the elderly, and finally to design products that would not alienate them.
If I could be an elder, perhaps I could then speak about the needs of older people everywhere as consumers.
The location of this investigation will be the Marlow Building, located on the University of Kent campus. The scenario being the Kent School of Architecture's end-of-year show, which invites and inhabits all demographics to one location to view varying sizes of work. The main principle of using a gallery as a case study would be to explore the varying perspectives one would take when viewing artwork. Therefore, creating a scenario where each impairment would create a different outcome to learn from. The virtual reality artifact shall be placed in one fixed location, to which can be removed at any time to experience both the real and the virtual, allowing for the viewer to determine their own results based from their own experience. The presentation can be paused at any time to view the visual impairment for longer. This can be done by pressing the controller's trigger once and then selecting the pause button. Using on-site surveys and the architecture drawings provided by Meld Architecture allows for the creation of a 3D model. To slowly build up the model allows for an adjustment period to the VR setting. Using the National Eye Institute database allows us to find how the visual impairment affects the eye and how the perceived vision may be. Each impairment will be in order of severity and what percentage of people it affects. Firstly, colour blindness, which currently affects 3 million people in Britain. The types of colour blindness are categorised under the effect called anomalous trichomocy. This condition is where all three cone types are used to distinguish light, but one type of the cone that perceives light is slightly out of alignment. This would therefore produce 3 different types of effects. Firstly, most commonly, proton anomaly, a reduced sensitivity to green light. Secondly, a deuteral anomaly, reduced sensitivity to red light. Thirdly, extremely rare trichotomy, a reduced sensitivity to blue light. Finally, monochromacy, the ability to see no colour. Moving from deficiencies to impairments would lead to uncorrected refractive errors. Refractive errors occur when the shape of the eye prevents light from focusing directly on the retina. The most common types of refractive errors include hyperopia. Distant objects may be seen more clearly than objects that are near. Myopia. Nearsighted objects up close appear clearly while objects from far appear blurry. The second visual impairment is cataracts. This visual impairment is a clouding of the lens. Cataracts affects vision by reducing the light that reaches the retina, which therefore creates a severe blurred vision. Over time, the clear lens will slowly change to a yellowish, brownish colour, adding a brown tint to the vision. The third impairment in this investigation is glaucoma. Glaucoma is a group of diseases that damage the eye's optic nerve, to which can result in a vision loss and gradual blindness. Similar to glaucoma is diabetic retinopathy, a visual impairment which is caused by diabetes. Diabetic retinopathy involves changes in the blood vessels of the retina, either swelling or leaking fluid. Then over time, abnormal new blood vessels start to grow on the surface of the retina, slowly obscuring vision. Finally, age-related macular degeneration. This eye condition affects the central part of your retina. This part of the eye needed for clear vision will be affected with an increase in blurred area that will grow over time, creating blank spots in your vision. The way we can use this investigation as a design tool is to learn specifically from our own experience. For instance, with severe impairments such as AMD, the focus can be moved towards the idea of touch, and how that can be used to guide the visitor throughout the space. Even with the work itself, turning artwork into 3D printed forms. Equally, from what we've learnt from glaucoma, an installation that strives for intimate narrow spaces, which allows the participant to view work individually, will be favourable compared to previous years' layouts. Finally, as noticed with colour blindness, the problem with distinguishing blues and purples, as well as green and brown, can become the primary design theme of the installation, rather manipulating the colours that can be visible instead, altogether creating an empathetic indicative gallery design. To conclude, with this design tool, a significant transition can be achieved from the traditional criteria for architecture to an alternative means of designing through a virtual layer, shifting architectural design from spatially led to experienced. As a result, developing an empathetic education to design for all demographics, not only our own.